Right, so in this example we have two numbers a and b, 60 and 54, and we find their prime factorization by repeatedly dividing them by prime numbers. And we put all these prime numbers in an ascending order. So we start from the smallest one and go to the largest. Okay, and we see that if there is some integer which does not appear in the expansion, then we take its power to be 0. Okay, so maybe we should do a correction here and allow 0 to be the value that I can possibly take. Okay, so in this case we can find out the common factors between a and b. For example, here 2 raised to the power 1, which is the smaller of 1 and 2, will be the common factor and will appear in the greatest common divisor. Here 3 raised to power 1 is the smallest of these two powers of 3 and will appear in the greatest common divisor. Similarly, 5 raised to power 0, being smaller of 1 and 5, will appear in the greatest common divisor and will not impact the computation, as it is just equal to 1. When we multiply these two numbers, we get the greatest common divisor, which is 6. So we see that this is a much simpler way of finding the greatest common divisor as compared to the previous examples, where we had to write all the divisors for all the underlying numbers for which we are finding the greatest common divisor.